let's do maybe one other thing here. And again, this isn't the perfect design. We're not going for perfection here, because some of the best ways to build this require some concepts that we have not learned yet. Most notably functions, which we will have in a subsequent video. But let's look at how we could maybe extend this so that we have O go automatically by a computer. Okay, so maybe we want to build this game where X is the human player and O is the computer player. Okay, in that case, right? In that case, we're only going to have X enter the row in the column here. Okay, and the computer player will do it differently, right? The computer player will have a different set of logic to be able, which will be randomly finding a location that's available to place the O character. Okay, so let's do this. This is the last thing that we'll do, and this is a bit of a harder step. Is we're going to get the computer. Computer plays random move. But I'm going to also indicate that computer plays a random valid move. Doesn't mean that the computer can go anywhere, because what if the space is already taken? All right, now I'm going to do this incrementally again. First thing I'm going to do is build this where the computer just goes anywhere within the 9 possibilities. Okay, now that doesn't really make sense because some of the spots are already taken, so we don't want to really rely on that. Okay, but I'm going to initially build it that way, right? So this first if here is going to be the human's move. If the turn is X, right, we're going to get the row in the column from the user. Okay. Now notice I put row and column up here outside of this code block, right? I want to be able, if I declared it in here, the scope would be limited to this code block, right? So it's important that I don't do that. I need it outside of that code block. Okay. And this is going to be the human player. We'll even call it that. We'll leave this comment. Okay. Else, if the turn is not X, it's O, it's the computer player's move, which is going to be random. Okay? Which is going to be random. The computer player, initially I'm going to allow the computer player to go any location that is a valid cell. And when I say any location that is between rows 0 to 2 and columns 0 to 2. All right, and I actually should say 1 to 3 because we're subtracting 1 down here from it. So we're going to say 1 to 3. Okay, so I'm going to say the row, okay, is equal to the random, we got a random number generator here, mod 3. Okay, let's look at what this does. Let's take a moment to think about random numbers again and how we generate random numbers. This function here, we call this rand, that will generate a random number, and it could be really, really large. Okay, it could be really, really large. We look at the documentation to find how long or how large. I think it's 32 bits, which would be like over 2 billion or so if it's signed. So either way, it's a very large number. When I mod it, I effectively divide it by 3 and take the remainder. Okay, this will force the random number to be between 0 and 2. Okay, however, I don't want the random number between 0 and 2. I want it to be between that, between 1 and 3. So I'm going to add 1 here. Okay, I'm going to add 1 here because this expression, this part, some very large number modded by 3 is going to be between 0 and 2 randomly, plus 1 makes it between 1 and 3 randomly. And then I'm going to do the same thing for the column. Okay? I'm going to do the same thing for the column. Right? Now, let's go ahead. Let's run this. All right, so it's got the human player first. Let me grab the middle. Okay. Oh, took that spot randomly. Okay. Let me bring this up so we can make sure we can all see. So now it's X's turn again, right? So if I took maybe the top left, okay. Hey, a pretty good random move there, right? And so on and so on. We can continue to play, right? Now let me actually keep the game going because I want to wait for the computer to do something that it's, to show one problem with this, right? If I say row 3, column 2, right? We still didn't run into a problem here, right? I could actually now end the game. I'm going to intentionally not end the game just so we can kind of see something happen. Well, it would still continue asking anyway, but we're going to say row 1. Let me just throw the move away. We'll say column 3, right? And let's see, where did... So notice something happened here. Okay, I didn't actually catch it before. We still have the check if the move is valid or not, right? And what's happening is, I didn't catch this the first time through, but it's really obvious here. Notice all of these invalid moves. What's going on here is we're randomly getting a spot that's taken, okay? A spot that's already taken by X or O. And then it leaves, right? Because it hits that location. It's hitting this, right? This is true. With the random row and column assign, this is true. It displays random move and hits continue. And then it randomly generates another move. So we notice that it continued hitting a bunch of invalid moves over and over again until it hit one that was valid. Okay. Continue doing that over and over again until it hit one that was valid. So we don't really want it to work that way. We want it to kind of check and especially not continuously display invalid move, right? That looks confusing seeing it that way. So we can make one additional kind of minor update here, okay, is we can have a loop here that continues to randomly get the row and column while, right, the row and the column equals space, right? So what does this do, right? And again, this is one of the reasons I'm doing this examples. I'm trying to show multiple concepts that we've been learning thus far kind of integrated together. The do will mean it's going to always, no matter what, hit this one time. Okay, one time, and then it checks. It says, hey, is that spot taken? Oops, and it's important. I need that -1 here. Okay, is that spot taken? Right. So we really want to say, while not. Oh, I'm sorry. Yeah, I was right the first time. So if we randomly found a place, right? If we randomly found a spot we randomly look at a cell. And we say, hey, wait, that location, that cell is taken, right? If we do that, right, then we want to come back around and generate another while we want to run it again, okay? So actually, I'm sorry, I keep going back and forth, right? We want to make sure we have the true false correct. So while we want to continue looping while this location is not blank, we want to leave this loop, right, when the location is free to take. Okay, so I just had to think about it for a moment to make sure we get it right. That we want to continue generating random rows and columns until the location is empty, right? And then that's a valid spot, and we can make that move. All right, that'll avoid seeing this whole sequence of invalid moves show up, okay, over and over again. So we can run this. Right, and now we're getting really close to our final answer. I mean, we can continue to improve it, but if I take the middle here, right, O takes that spot, right? Maybe I take the top left, O went there. Maybe I block O, right? okay, when kind of a dumb area, and then I say, well, row 1, column 2. Okay, now the game still keeps going, right? But notice, right, O is now moving and playing, and it's not constantly just saying invalid move for the random, based on the random spot that was taken. It just continues to, if it's taken, it just can, eventually it will find a free spot until you've taken all of them, and then it will run forever. Okay, so I'm going to stop this example of the game now here, but I expect that we'll follow up with it later on and kind of expand on it, and we'll look at maybe using some functions as a way when we introduce that topic to improve this further, okay? But that will be a conversation for another day and another video.